All right. And finally, I'd like to show one last video of how to use Mathematica to calculate some of the numbers that I provided you in these videos. Mathematica becomes a lot more reliable than a handheld calculator on problems like these because you can store values as variables, and this allows you to simplify your equations when you enter them into calculation cells. For example, I can store omega inside a variable that I call omega. And this is equal to 1,372 watts per square meter. And I can store A inside a variable that I call A for our albedo, and A is equal to 0.3. I can store sigma in a variable that I call sigma, and you'll remember that sigma is equal to 5.67 times 10 to the minus eighth watts per square meter per degree Kelvin to the fourth power. And it makes it really easy for me to enter a formula like 3 over sigma times omega over 4 minus a omega over 4 inside a set of parentheses, all raised to the 1/4 power, which is what we had for our Earth stock temperature when we were solving our two-layer climate model. If I evaluate this expression with the stored variables, I get the same result that I presented in our earlier videos, with a little bit more accuracy. As we will see in class, Mathematica is really good for carrying out calculations, but more importantly, it's really good for solving systems of equations. And this means that you can use Mathematica to do all of the algebra that we presented in these videos, and you'll be especially grateful for this when we put together our final climate model, which is a bit more complicated than what we've been working with up until now. Long story short, be ready for more complicated climate models and be ready to use Mathematica to solve those climate models when we get together in class.